task domains in AI. So next thing which we'll be studying today is the data. I hope my screen is visible. Yes, students, is my screen visible?
Yes, ma'am.
Okay. So next thing we'll be talking about is data today. Now, all the while we have been talking that we want to make the AI systems intelligent and we want them to learn from the experiences in the same way as we humans learn. Now, how this can actually be done? So here comes the role of data in AI. So suppose I have this table with me, table to predict the price of houses. So let's say in one column I have the size of the house in square feet. So these are the sizes of the houses and these are the prices of the houses, right? So data can be very specific to the organization. So let's suppose if I take this as field A and this price as field B. Now my objective is to from A I should be able to predict B. That is from the sizes of the house I should be able to predict the price of the house. So if you people have been working in the area of machine learning, so you people might be using the data to do these kind of tasks. So now the idea is to give all this full table which you see there, to give all this table to your machine learning system so that it can learn that when the size of houses are these, what are the prices of the house. Then when you give it a new size of the house, let's suppose a size of 746, it should automatically give me some price value based on the relation between this data, this table, which is already given. Now, what if I have one more attribute in this? Now here, apart from the size of the house and the price, I have number of bedrooms also here. So you can see in this case both A and this B. If I take this as A, or even in this case what I can do is I can take both of them as A. So this A is used to predict this B. Now these values, this first column and the second column, are known as the features of our data. The features which have something unique in them, or the combination of the features could give you the final output, the final price which we want. We can also do, suppose if I have this data here, what I can do is I can take the price of the house, and based on the price I can train the machine to learn the size of the house in square feet. So this way also we can do that. Based on the prices are given, and based on that the machine learns to predict the size of the house. So again in this case the size of the house and the number of bedrooms together in the second table will make the complete feature set. Both these columns will be the feature set, and based on these two, this 1 and 2, I will be predicting the price of the house. So again, having good data is very important. Based on the data only, you make the machine learn. So in order to make the machine learn, we have the machine learning algorithms. So the machine learning algorithm learns from the data and make the system intelligent. So that's how machine learning and artificial intelligence are related. So if the model is able to learn from the data, learn from the experience, and it is able to think. So if you are given a new size of the house, let's suppose I have a new size of the house and new number of bedrooms. So in that case, so if suppose here I have a house, let's say whose value is 736. So if I have a house whose size is 736 with, let's say, again one number of bedrooms, so in this case what would be the price of the house? So if I want to do this, now in this case, the machine should be able to, already learn the relation between the size of the house and the number of bedrooms, and on this data it should be able to give me the price. So it is learning and it is thinking. So when it has new data, it thinks what could be the size of the house, what could be the price of the house. So, and it learns, it thinks based on the learning which has been exposed with the help of this data here. So the machine is able to think, is able to give you the value. So this is where the machine learns and gains the experience, and then we say that the machine has this artificial intelligence in it, or the machine is artificially intelligent. In third case, similarly, if I have this data here, so even in this data, you can see there are some images here, some label here. Again, the machine learns that this is an image of a cat, this is not a cat. Again, this is a cat, this is not a cat. Again, we give the data to the machines, and they try to learn from the data. Now, when you talk about the data, how to acquire this data, the data which I have been telling you, so that machines can learn, they can have this artificial intelligence in them. So they can, so there are many number of ways. One is the manual labeling process. So in this manual labeling process, what we do is we have some set of images, like we have these images, we manually label them. So if I have the image of the cat, I myself will label it, it's a cat, it's not a cat, so suppose my idea is to make the machine learn whether the image is of a cat or not. So obviously I will feed them different images where the image is either of the cat or not cat, only these two labels, so that it can learn that this specific image is for the cat, this is not a cat. This is how you train 3 to 4 years child to recognize the things. So you make them see different objects there, then you tell them, this is a bat, this is a ball. That's how you make them learn. So in similar way, we want the machines to learn. So you feed them different images here. Let's say different kind of images of cats where they have been rotated, the different variants of cats we give them, and some, and many other images which are not cats, so that it can able to distinguish. Then first is where we manually label. So let's say if I have 1,000 images with me, I will be manually labeling them, or manually annotating them the labels, manually giving them the labels. Second thing could be again from observing behavior. So let's say I work in a factory. So where we can say that this particular machine as at this temperature and this pressure does not become faulty. So I have been recording the observation of different machines at, let's say, different instance of time also, that at this time the machine was faulty, or when the user purchased the machine at this time at this price. So yes, the user purchased, so at this particular user id at this time with this price did not purchase the machine. So by observing also we can build our data set. Third very important data set which most of the people do is to first download from the websites. Now again, when you talk about downloading the data set from the website, here also you can, in the first case, you can download the data from the website. So we can download many cat images from the website. So what is the difference between the first one and this one? So suppose not in every case, like in the first case, if I want the image of the cat, or let's say if I talk about the task of sentiment analysis. Okay, let's say visual sentiment analysis, if you people know. So in visual sentiment analysis, what happens is, so suppose I have the image of a river flowing. Okay, I have a beautiful picture where a river is flowing and a beautiful scenery. So this will represent or convey a positive sentiment to me, a positive emotion to me. So again, if I have another image where, let's suppose, there is a fire and there's a building and the building got fire. So this is a negative sentiment. This is conveying a negative sentiment to me. So what I can do is, suppose if I want to get data for this task, for the sentiment analysis task, now one way is to manually annotate it each picture as positive or let's say as negative. Another way is to collect the weak labels. So these are the strong labels. If I talk about this cat, not cat, because these are the strong labels, means these are the actual labels which actually denote what is there inside the picture. Now, if I talk about this task of sentiment analysis, although I need labels such as positive for this first image, negative for this first image, because the idea is to classify the images into positive and negative. But again, I don't have the positive and negative as the strong labels. I will collect weak labels. So suppose if I go to Flickr website or Getty Images website, I go there and I download the images from, let's say, a keyword as river or a beautiful sunny day. Suppose I download the images with these kind of keywords there from Flickr. So beautiful sunny or good day. Suppose I go and fetch the data with these keywords. Now these keywords, if I have beautiful sunny day, so there are chances that mostly I will be getting the positive sentiment images from there. So what I do is I just use this keyword there and download all the images. So in this case, the images that have been downloaded are weakly labeled because we have assigned a label which will help me to classify the data and into the strong labels. But again, I am not so sure with with these pictures, because it might happen, I have used the keyword such as strong, the good day or a beautiful river, but it might happen some images get downloaded which are not exactly related to this particular keyword, and some are negative, some are conveying negative sentiments, still they are being downloaded. It happens when we scrap the data, when we download the data. So in that case, the data I have is a weakly labeled data set, but still it is possible that, let's say, out of 100 images, I might get 60, 70 images which are actually related to that weakly label exactly, and thereby I can directly annotate them as a positive sentiment. So this is a one way to download the data set from website. So people search for weakly label, because if you go and type positive sentiment images from Flickr or Getty, you might not be able to get those images. So you see in which website, what are the keywords there, how can I download the data set, do I have to weekly label the data set and download the data set using weekly labels, and then I again annotate them, or let's say I just go through the pictures and quickly annotate them and see, and yes, these were the strong sentiments. Next is the partnership. So we also go for partnership. Now here the term as crowdsourcing comes up. So let's suppose if there's a very famous company, or the feature which we have, that are the eight Amazon Mechanical Turk, AMT. If you people have heard about the AMT. So what AMT does, AMT stands for Amazon Mechanical Turk. So they again, the company gives the data set to them. Okay, they themselves annotate the data and gives back to the company. So again, they now, why we do that, because they follow a very organized way to label the data, because it is not that you have the data with you and you just annotate the data yourself. Annotating the data is correctly annotating the data is very important, and collecting the correct images is also very important, because these are the things through which your model learns. If they are not correctly synced, your model will never learn. And there are many other things when it comes to data. So suppose I give the images to the AMT, Amazon Mechanical Turk. So let's say they take any three people or any five people, and each of the image in the data set goes to all these three. Let's say if I have three people, goes to all these three people. They say that yes, this is, suppose the first person says that this is the image of the cat. Second says yes, this is the image of the cat. But third says no, this is not the image of the cat. So the majority vote
The
here
vote here
is
is
for yes.
for
Yes,
yes.
anyone wants to say? Okay. So the majority vote here goes to the Y, the yes label. So the image here will be labeled as Y. Yes. So this is how they do. So they take the odd number of people, three people, five people, and then so many people are being given these images. They correctly label them, because see, now here you can see the image is just of the cat or not, but in real life we have many complicated problems, and building the data set for those problems becomes very important for you. So this is the example of a partnership. You can go for the partnership, and also to various different organizations also you can go. You can ask them to label the data. You can go there and acquire their data also. So this is how the data is being acquired. Now the term comes use and misuse of data. Now it becomes very necessary to have a correct sync when you are working in the domain of AI. Correct sync between the organization, between the different department of the organization. Let's say if I have the IT people and AI people in an organization. So suppose people are working in a project. So usually what we do is we use IT people. So let's suppose I use IT people to label the data set, collect the data set, label the data set, and the AI people, they are then going to process this data set and work on this data set. Now it becomes very necessary for the IT people to be in constant touch with the AI people. It's not like you are given the task to please build this data set, and I need the images of the, let's say I need a data set for one kind of task. So suppose I need this one feature set, and this is the class label. So please you know collect this data set and label this data set for me. If I tell this to the IT people, now for this particular task, let's say the IT people takes 5 months, 6 months, 7 months for this, and after collecting all the data set, it goes to the AI people. Now it might happen that after looking at the data set, the AI people feels that, what if we would have one more feature set in the data, or one more feature in the data, then the entire learning process could be very easy. So it's very great if you could add one more label, one more feature set there. So, we can just not randomly add this feature set. We'll have to see that, combination of these feature set is giving me the exact label or not. So again, you have to go through the entire data set in this case. Now, therefore, it is always required that, when you start preparing your data, labeling your data, you should continuously have a touch with the AI people to show them, to get their feedback. It's not like that you are given the job and you are left, because many companies were doing like this. So many companies, the job were given to the IT people. They sit around, they work on that data, and then after 7, 8, 9 months, even 1 year, they go, because collecting, making data takes lots and lots of time and efforts. This is a very important step. So then after this, even if you go and you see, the data which you have acquired is not of great use. And even this happens when new startups or new AI companies are being just have just started working. What they do is, suppose any such problem they want to work, so they directly contact some organizations to, please give me this data of yours. We need this data. We'll be paying you. Giving you this. So that's how they acquire the data. But what happens is, when they acquire the data, after that, when they start working, they realize that, no, we do not need this much amount of data, or we don't need this data. So in that case, the time and money gets wasted, and this is how majorly the AI projects stop working, because the big people, they were not analyzing what exactly they want from the data. So that's why, having good experienced people and, the use of data comes in picture. So it is very important that you should know what you want, and how you are going to proceed with those things. It is very important to be in constant, because these things of getting the data, what data you want, obviously the higher people do that. So many a times they do not have so much of discussion with the actual core people who are going to build. So, or even the core people who will be working, they do not analyze so much that what exactly we want in the data. So there for so much confusion and such things come up. Now data, it can be messy. So if I talk about this data, the data which I acquired, suppose, so it can obviously be messy. It can have some incorrect label. Suppose in this case, if I have this price, it might be incorrect. So I have to look and see whether the data is correct or not, whether there are any missing values here. So you can see there are many missing values in the data. So you have to, when you work with the data, you have to see all these things, and accordingly you have to process your data. What if there are missing values in the data? What if there are incorrect labels in the data? So for all these things, we have different approaches. So this is how you have to deal with the data here. And obviously data can be of different types. So we can have images, we can have audio, we can have text. It is of different types. Now comes the qualities of AI. So one such quality of AI is the intentionality in the AI system. So intentionality means the power to do something, or the power to make some decisions. So AI systems, they are able to make decisions using the real-time data, and they can use the sensors, the input, to gather the data from different sources. And obviously we know they have the massive amount of storage with them, the processing speed, all those things are very quick. So this is one of the qualities of AI. So these are some theoretical concepts, that it is intentionality, then intelligence. This we already know that how intelligent these AI systems are, and what kind of intelligence they possess. Adaptability, again, they are able to adapt to different conditions, in the sense, if you are using the sensors and camera, they use sensors and cameras to get the output, and based on the you can say the problem statement, they give you the output accordingly. So if you talk about the self-driving cars, or the human drivers, where they make sense, it's human drivers that can make sense of ongoing traffic and vehicular conditions. So accordingly, what is the current situation there, do we have to increase the speed, or when we have to press the brake, and accordingly, based on the input that it receives, it is able to adapt in itself and give you the correct output. So these are some of the qualities of AI. Now the agents in AI. So this I've already told in the previous lecture. Agents are something that are able to get the input from the environment and can, so it gets the input with the help of sensors or various input cameras or any such things, and it can give the output to the environment. So the output again could be anything like in self-driving cars, the speed gets slows, the cars are automatically, they control the gears and the brakes and everything. So that's how the output is being shown. So even as I told that we humans, we are also intelligent. We capture the data from our eyes, ears, and then we give the output with the help of, let's say, our mouth or the hands. So that's how the concept of agents comes up in the AI, artificial intelligence. So these are again some of the areas and dependencies of AI. Now, as you can see, this area is dependent upon many areas which are there. So let's say if I talk about the first area, that is the searching. So in searching, the best example could be the game playing. So if you look at this tic-tac-toe game here, okay, so how, like, I think if you have done the AI subject, studied the AI subject, so you might have studied this example. So suppose if I in the game playing part especially, you use this searching algorithms a lot. So searching could be anything. We can use the BFS, breadth first search, depth first search. So these are the informed searches. Informed searches means you already have some information. So if you go from one place, let's say from one node to another node in, let's say, a depth first for search or a breadth first search, so you already have some information maybe on the node, here, the distance or any such thing which is there. But there are some, you can say, algorithms which are uninformed, which do not have the exact information. So those algorithms are also there in the searching part, searching trees part. I will not go into the complete depth because that is not in the syllabus. So if I talk about this game, so in AI, how this is done is, suppose I have this particular condition here. Okay, now let's suppose I am the one who will win when the X one, all the X matches. So let's say in this case where all the X matches, here you can see I got the plus 10 points and opponent is the one who is in red, making the 0. So if I have this condition, so internally what could be the next position? So if you see now in this particular case, I have to, in this particular case, it's my turn. So I can place this X in this part. So you can see these three portions are empty here in first condition. So I can place X here or here or here, third case. So if I place X here in first case, then again, what are the two possibilities? If I place X here, what are the again two possibilities where the opponent can play? And if I place X here, in this case, I already won because you can see all the X's have been matched and I got this plus 10 point here. Again, if X is here and if opponent places 0 here or 0 here, what could be the possibility? Now in this case, the opponent wins because all the zeros are matching, so I get minus 10 points. So this is how internally the searching happens. So in the leaf node, all the leaf node will have all the values here, that plus 10, minus 10, what are the actual values you have, and based on that searching happens. What could be the best possible way for this? After this point, what could have been the best possible ways where I won? Suppose I won in this particular case, I won in this particular case. So these are all the cases where I won. This is how searching happens mostly, in case of especially the game playing part. Next is the knowledge representation. So when it comes to knowledge representation, this is how you represent or store the knowledge inside a system. So very basic thing, if I can use the simple relational knowledge means I can store the information in a table. Let's say I have different players, their weights, their age. I can store the values inside a table, or I can also use some graph based on inheritance. If you people might have studied inheritance, or the instances, like say if I can say that Peter is the one who plays cricket. He is a cricket player. So Peter is an instance of a cricket, and cricket here shows that cricket player, and he is an adult male. So that's how you can see that Peter is a cricketer player and he is an adult male. So this is how graphically also we can show the knowledge. If anything we want to store, if we want the machines to learn, or we want to store the data. So this is how the knowledge is being represented. This is very basic things here. You people might already studied these things, so that's why it's a very basic thing here. Then comes the logic. Again, logic is again a way of knowledge representation only. So you represent the knowledge using propositional and predicate. This also, if you people have studied the discrete subject, discrete mathematics, you people might have studied about the discrete and propositional and predicate logic. So what is the difference between them? Predicate logic. Why do we use the predicate logic actually? Anyone? Let me ask then. Himanshu Mittal. Why do we use Himanshu? Why do we use this predicate logic? Himanshu Mittal, are you there? Because then from next class onwards, if I ask the question and if I do not get any response, you will be marked absent then. Okay, Himanshu Mittal, one. Uh, Next, Anshul Trivedi. Yes, Anshul. So I think this is the best way to see who all are actually there and who all are not. Anshul, Hemant.
Yes, ma'am.
So at least you answered. So Hemant, any idea about the logic, predicate logic? Why do we use it? We already have propositional logic, which I suppose you know.
Uh, yes, ma'am.
So why do we need the predicate logic? Studied the discrete subject, discrete structure subject.
Yes, ma'am. Discrete mathematics. Yes, ma'am.
Chalo, okay. Just tell me anything which you know about this logic, propositional or predicate logic. What do you understand? Anything about this?
Actually, I forgot, ma'am. I'm trying.
Chalo, okay. Okay. So uh, we have logic. We have two kind of logic, propositional and predicate logic, which you people might have studied. So this is a way to represent the knowledge. Like if I have this statement here, if it is hot and humid, then it is raining. Now how do I can store this information in the system? Because system do not understand these words, these sentences. So there comes the logic to store the information. So two such kinds are propositional logic and the predicate logic. So if I talk about the propositional logic, so what can I do is I can represent these individual sentences like it is hot by P, it is humid by Q, and then it is raining by R. Okay, I represent these three things with these three alphabets, with these three alphabets here, and then what I can do is I can use some terms uh, to represent the complete statement. So term is basically that these was let this and symbol you see here. Let me just change this and symbol which you see here. This denotes this and. which is here. And then this arrow, it denotes this then word, which is here. So this is how you represent the information with the help of the logic here. So you have different and or symbols which you people might have studied. So this is how you can represent the things here. Now, why do we need the predicate logic? Anyone, why do we need the predicate logic? So predicate logic is there because predicate logic, it helps to uh, uh, represent the variables with a specific domain. So what that means is there are some words, or you might have studied about the quantifiers, if you can remember the quantifiers in discrete mathematics. So there are some terms like some quantities which cannot be represented in propositional logic. Then we have predicate logic, which is more powerful than the propositional logic. So we can have more control in this predicate logic to represent the values, to represent the quantifiers there. So if I have terms like some, I need some water, or please give me more water. So these terms, some, more, all those things can be represented with the help of predicate logic. It is much more powerful than the propositional logic. And thereby we have this predicate logic to store these things, because in real life we do not have the, now so we are not just dealing with the binary logic, we are also dealing with fuzzy logic. So apart from 0 and 1, we are representing something which is between 0 and 1 also. So for that we need the predicate logic, which is much more powerful and which can represent many different quantities here. So again, logic is yet another way to store the information in the system. Yes, next, this is something interesting, the AI timeline. So this AI timeline shows you the progress of AI throughout the years. Some of the major progresses basically. So the starting was from 1950 onwards. So in 1950, somewhere in the 19th century, a very famous Turing test came up, which I think some of you might be aware of. So Turing test basically was introduced by Alan Turing in 1950. So this is the paper, Computing Machinery and Intelligence, you can go there, in which he considered the question that can machine think. So what he did is he performed an experiment to uh, find whether the machine has the artificial intelligence or not. So suppose these are the two systems here. Now in what he did is he created, let's say there are three rooms here. Okay, in one room a computer is there, which we assume that it has the artificial intelligence. In another room we have a human here who will be responding. So in this is the player A, let's say this is the player B, and in third room we have a player C, that is an interrogator. So interrogator asks the same question from player A and player B. Okay, so and it gets the answer from both the players, player A and player B. Now the answer which he gets is when, if he is able to recognize, if the interrogator is able to recognize that the answer which I got is from, let's say, player A or is from the player B. If the interrogator is able to recognize, then we say that the machine does not have the artificial intelligence. And if the interrogator is not able to recognize whether the answer which I have received or the answer which I have received, which answer corresponds to the machine or which corresponds to the player, then we say that the machine has the intelligence, the artificial intelligence in this. Because the next person here is not able to distinguish whether the reply here is from the human or is from the machine. It is as good as the reply from the human. So in that case, we say that it's a the machine has the intelligence. So this test got very popular at that time, and many people start using this Turing test to see whether a machine has this artificial intelligence or not. So in this particular era, the idea of machine learning and can machine thinks and can it be programmed to the level of human beings came into the picture. Now, then again, after 1915, 1955, the term AI was actually coined. That there is something called as AI after 5 years of Alan Turing. That AI was actually coined. That AI is something there, which is the science of engineering and making machine intelligent. This came up. AI was born. Then some robot, Unimate robot, a bit of robotics kind of things came into picture. These are just the very popular or some of the very crucial things which have been highlighted. There are many other things which were going. So let's say in 1964, the Eliza, the chatbot was developed by the MIT, the first ever chatbot, which I think the major chatbot which got some popularity at that particular time was developed by the MIT. So again, this is the interface of the Eliza here. So you can go and check out the this Eliza. Now, if you type here something, so you will not get such good replies. As you can see, today's Alexa and Siri and every other chatbot here, they are much more refined. Obviously, here you will not get so many so good answers. Let's suppose the this user asked that what's your name. Suppose he typed the query what's your name, then it reply we don't need names here. So this is just an example. If you type some other thing, you will not get as good as answers as you might expect them. But still, at that particular time, this was a very great thing which came into picture. So this was the Eliza here. Then in 1966 we have Shakey. So Shakey was the mobile, the robot. If you if you know about this, so if you know about this, the Shakey, the robot, its name was Shakey because it used to, I think, shake a bit. So you can, I will play this YouTube video. You can see that how actually the scientists came together and developed this Shakey, the first ever robot which were having the artificial intelligence in that. So I'm just playing this video. If in case the video is not visible or not audible, just let me know. I'll then do accordingly. So I hope it is.
Ma'am, there's no audio.
Is there any audio?
Mhm.
Okay, 1 second. Go to the site then. Just give me a minute. Now just let me know whether the audio is there or not.
No audio, ma'am.
Second, even my audio is.
Ma'am, you need to share your screen with computer audio.
Yes, correct. So I think in that case, the PowerPoint one will work. Just let me know now.
Shakey
Audible, ma'am.
is a global intelligent robot, embodying numerous breakthroughs in artificial intelligence, robotics, computer vision, navigation, and other research areas. The robot was developed from 1966 to 1972 by SRI International, then called Stanford Research Institute, and its legacy and impact are still very much alive today.
Shakey's really the great-grandfather of things like self-driving cars and even military drones.
The hardware was really pretty primitive, but the software architecture and the software algorithms are what changed the world.
I think we all thought we were doing really interesting stuff, so it didn't really dawn on us that we were doing anything special.
Shakey established a position about what we should be thinking about as possible, as feasible.
To understand why Shakey is so important, we have to go back to 1966, and we have to understand where AI research was at that time.
Well, you have to remember that it was pretty much of a green field when Shakey started. All over the country and even outside of the United States, people were beginning to build the components to artificial intelligence. Nobody had tried at the time that Shakey was launched to integrate all the components of AI and robotics into a single moving vehicle that could reason about the world, could sense the world around it, and could take actions.
Prior to 1966, there were no robots, or at least not intelligent ones. The concept of an intelligent robot was limited to the realm of fiction.
You will meet a charming character in The Robot, always at your service.
When you read the title of the original proposal, it was something like a mobile automaton for reconnaissance. And the reason we called it an automaton was because until Shakey, you couldn't go to a funding agency and say, I want money to make a science fiction kind of device. And so we needed a name. And finally, Charlie, in his inimitable fashion, said, it shakes like hell when it moves. Let's just call it Shakey.
Key components of Shakey's hardware were a TV camera to observe its environment, an antenna radio link, bump detectors, and a push bar to move objects.
My role was mainly get the images and get whatever coordinates they needed to determine where they were and extract the information from the image. I remember when I first saw it, gee, that looks like a dishwasher on wheels.
While charming, Shakey wasn't impressive for its looks. It was the AI and programming advancements that made it famous.
We structured Shakey software in 4 distinct layers. And that was the first time that a layered architecture was used for robots.
Shakey's pioneering software architecture paved the way to a new era of AI and robotics. The SRI team later developed Flaky, a research robot that demonstrated fuzzy logic and goal-oriented behavior. Then came Centibots, one of the earliest projects in swarm robotics, where 100 autonomous robots demonstrated the ability to map a complex area collaboratively.
I like how it's code that isn't just turning numbers into other numbers. You get to see the thing come to life right next to you.
Shakey also inspired research in natural language-based interactions, leading to the popular speech-based technologies that we use today. Shakey's breakthrough in computer vision is now used to help drivers stay in their lanes. And every time you get driving directions on your phone or a navigation system, you are benefiting from the A-star navigation algorithm, first invented for Shakey. Even NASA's Mars exploration rovers use navigational techniques that were first launched with Shakey.
The future is things like potentially having teams of autonomous aircraft that could go out, for example, and do firefighting, and doing this either fully autonomously or potentially in tandem with human-piloted aircraft that can go out and work with them collaboratively.
Shakey now resides in the Computer History Museum, visible to hundreds of thousands of visitors annually. And in 2017, Shakey was honored with an IEEE Milestone Achievement Award.
The Shakey milestone is important because, first of all, Shakey is the world's first mobile intelligent robot. In addition, this is the first IEEE milestone in the areas of either robotics or artificial intelligence.
Looking back, More than 50 years after the Shakey project began, it's inspiring to see how one small team can make such an impact. How one ambitious idea continues to benefit our lives. How one robot changed the world.
We didn't realize, I think, any of us, what the significance of this was. We knew we were the first, but nobody knew where it was going, and I don't think any of us would have predicted what happened.
Shakey planted the flag way out there. It's a model of the kind of ambitious projects that we should be looking at in the future.
So this was it. So I think interesting of how the Shakey was developed with and they were not so sure how this first robot would be getting so popular that nowadays also the uh, basic uh, thing or the basic algorithm on which it was developed is now also being used. So this is how the softwares industry work. You obviously not everything is developed from scratch. You obviously take some previous let's say the code which you people take or the previous idea, and that's how you proceed. So this was one such example of Shakey. Then yes, then the term AI winter came. So what is AI winter? Now AI winter is a point. There were two major AI winters that happened. So it is a time when the area in AI gets reduced funding because the people that are there in AI is not, the area of AI is not giving so much inventions or so much efforts are not being put into this area. That's why this area is getting less popular. So reduce funding, and maybe the projects which people are doing are not, if they are not able to come up with something great, the projects were getting failed again and again. So the government, then if this happens, then obviously people think that should we invest in such projects or not? Because it's not that one such project of AI is there, everyone is using AI, so any other person which is working on AI is also getting the same good results. No, it might happen even after the Shakey. Many people then started working with robotics or any other thing related to AI, but they are not getting good results. So in that case, the funding also stops. So if the funding stops, then obviously how will they proceed with the project? So there were two major AI winters, you can see. So yes, one more thing, the triple AI. Any one of you have heard about this triple AI? The triple AI conference is also, I think people might have heard. Anyone? These all things are very basic and important. You should always remember this. And so triple AI stands for the Association for Advancement of Artificial Intelligence. It's a very old society related to the AI area. So you can go to this link or you can search online what is triple AI. So triple AI, what it does, it uh, tells you the recent progresses related to the field of artificial intelligence and how that is done. They hold a conference every year. So I think next year it will be a 36th or 35th conference. So that's how from 35 years it is holding the conference. So previously, let's suppose in 19th century it used to hold conference after every 2 years, but nowadays I think from 2000 onwards it is going holding the conference I think every year. That's how from 35 maybe let's say in previously after 2 years or 3 years it was holding, I'm not so sure, but it is there to tell you what exactly people are doing in AI nowadays. So you write research papers. Many of you might have written research papers in your previous years. You might have submitted to some conference or journal paper. So Triple AI is the topmost conference in the area of AI. So if you go there and if you search, so all the latest work is there related to AI. So many different, the Stanford, MIT, many different university students, teachers, faculties, everyone, they whatever new thing they do or they think they have done something good, they send their papers to this AI. and they AAAI conference, and then they review, and then they accordingly give the results whether it should be accepted or not. So they only accept if you come up with something novel, something good idea or technology or any such thing. So it's a very important society. If you want to work in AI in the future, or if you want to see how AI has been progressing, because we do not know where to look, about the exact progress of AI or what exactly people are doing. So you can definitely check out this triple AI. There'll be many papers related to AI, so you can see exactly on which topic, which area people are using this artificial intelligence, or what people are doing from all over the world, from good universities. So you can definitely check out, and if even if you want, or if you can come up with something good, you people can also send your research papers or ideas to this triple AI conferences, because having one paper in triple AI conference is a very big thing if you actually want to excel in this field of AI. Even for the industry people or Google, Microsoft, everyone, they have paper in this triple AI. They work, if they work something good, something great. So this is the Triple AI Association for the Advancement of Artificial Intelligence. So you can definitely check out their website and see how they work. So next is the era of 1997, where Deep Blue came up.
Ma'am,
Yes.
the cast time is overrunning now.
Okay. Okay. Okay then. I am stopping now. 1 second. Also, one thing, I